Hello students, this video lecture will cover section 9.5, dilations. Our learning goal for this lesson is to understand dilation images of figures. The key concept of this lesson is dilations. A dilation with center C and scale factor n, where n is greater than 0, is a transformation that holds two properties. The image of C is itself. So any point that's on the center of dilation remains there. But for any other point, that point is moved n times the distance that it was originally. The image of a dilation is similar to its pre-image. So you can see here the original distance from C to R becomes n times C of R when we take C to R prime. And because of this, the figures actually get a little bit bigger as they move further away from the original pre-image. So this black figure is the pre-image and the blue figure is the image. If the scale factor is between 0 and 1, the pre-image will then get closer to the center of dilation and become smaller. So a dilation is an enlargement if the scale factor is greater than 1. And a dilation is a reduction if the scale factor is between 0 and 1. So you can see here on the left we have an enlargement. The center is at A. That's easy to tell because that's the only point that remained the same. And it's an enlargement because you can see this original distance from D to C was 2, and the distance in the image from D prime to C prime is 4. So we're going from 2 to 4, and that is a multiplication of 2, so the scale factor is 2. Here we have the black figure EFGH, which looks to be some type of trapezoid. The center here is at C, so you can see that this is a reduction because E prime, F prime, G prime, H prime is smaller than the original figure. And we can see that the original size of EH was 8, and now E prime to H prime is 2. So to get from 8 to 2, we have to multiply by 1/4. So this figure's gotten smaller. So question number 1 asks us to find the scale factor. So we have triangle X prime, T prime, R prime, which is a dilation of triangle XTR. The center of this dilation is at X. The first question asks us, is the dilation an enlargement or a reduction? So this question is definitely one we all want to get right. So we have the original picture, X, R, T, and it has become X prime, R prime, T prime. So the blue figure is certainly larger than the black figure, so this is definitely an enlargement. Now the second question is one that definitely gives people fits. What is the scale factor of the dilation? So we start with X to T, and eventually X to T becomes X prime to T prime. So originally from X to T, we can see that this is a distance of 4. And now this is the part where people make mistakes. They go from X prime to T prime and they see this 8 and they just write down 8. Well, that's not what's actually happening. We're going from X prime all the way to T prime, so you can see that we actually have to take the 4 and add the 8. So this is 12. So then we have to ask ourselves, first of all, this is an enlargement. So I know that the scale factor has to be greater than 1, and I have to ask myself, 4 times X equals 12. So by dividing both sides by 4, we get that the scale factor is going to be 3. So each of these pieces in the larger triangle is 3 times the length of that same piece in the smaller triangle. So here we have J prime, K prime, L prime, M prime, which is a dilation image of JKLM. The center of this dilation is at the origin. So this time, it seems obvious that the black figure is larger than the blue figure, so this is definitely a reduction. Now that helps us a lot because we know for a fact now that the scale factor of this is going to be between 0 and 1. Now we have lots of choices here, but whenever possible we always want to deal with vertical or horizontal lines. We could certainly use distance formula to find the length of j to m and j prime to m prime and then compare them. But one of the things that I want you to take note of is the fact that we have this vertical line here and this vertical line here. That's going to make our lives much easier. Because with vertical lines, we can just count the number of squares. So you can see the original distance from K to L is going to be 4 units. And the now distance from K prime to L prime is just 2 squares. So we have the original, and we have the image. And so just like we did last time, we have the pre-image on the left-hand side, we have the image on the right. So the pre-image times the scale factor is going to have to give us the image. So dividing both sides of this by 4, we find that x is 1/2. So the scale factor of this dilation is 1/2. So just as a note, all dilations in the coordinate plane have the origin as the center, unless stated otherwise. So you can find the image of a point by multiplying each of the coordinates by the scale factor n. So here you can see the original point P is at x comma y, and the new point P prime is at n times x comma n times y. So if we go back a slide, we can check. We have this original point J, which has coordinates at 0, 2. If we multiply 0 times 1/2, we still get 0, and if we multiply 2 times 1/2, we get 1. So you can see our scale factor certainly works in this case. If we take the coordinates of m, we have -2, -2. Multiplying each of these by 1/2, we should get -1, -1, and that is in fact where m prime is. Our second question has to do with finding a dilation image. So given triangle ABC that has coordinates a at 2, 0, so let's go ahead and plot that point, 2, 0, -3, 1, and 0, -2. So here are the vertices of the triangle that we're looking at. So let's go ahead and connect these points to actually make our triangle. So here's our original triangle, triangle ABC. Now with a scale factor of 2 and a center of 0, 0, what I want to do is I want to take the x's and y's and double all of them. So 2 times 2 is 4, 0 times 2 is still going to be 0. B is going to be at -3 times 2, which is -6. 1 times 2 is at 2. And C is going to be 0 times 2, which is 0, and -2 times 2, which is -4. So let's go ahead and plot these points. So we have 4, 0, -6, 2, and 0, -4. And if we connect these points, we can see the triangle when multiplied by a scale factor of 2. So we get a triangle that is twice the size. Same idea, we have a center of 0, 0 and a scale factor of 1/2, so I'm going to take half of all these coordinates. So half of 2 is 1, half of 0 is 0 for point B. I have half of -3, so that's going to be -1.5, and half of 1, which is going to be a half. And for C, I'm going to have half of 0, which is 0, and half of -2, which is -1. So for A, I get 1, 0. For B, I get -1.5, half, so that's going to be a point right in that neighborhood. And for C, I get 0, -1. And so if we connect these points, we can see that this resulting triangle is going to be exactly half the size of the original black triangle. So remember, as long as the center is at 0, 0, we can take each of the coordinates and just multiply by the scale factor. So problem 3 asks us to use the scale factor to find length. So we have a magnifying glass that shows an image of an object that is 7 times the object's actual size. The photo shows an apple seed under this magnifying glass. And we're asked, what is the actual length of the apple seed if the apple seed is 1.75 inches when magnified? So oftentimes I like to use words to describe this situation. So the original, whatever the original is, 7 times magnified equals the image under magnification. So we know that the image under magnification is 1.75. So we have 7 times some number gives us 1.75. And so if we divide both sides of this by 7, we find that x equals 0.25. So what is the actual length of the apple seed if the apple seed is 1.75 inches when magnified? It's 1/4 inch. So that apple seed is 0.25, and then when magnified, 1.75. So this apple seed is 0.25 inches. So that concludes section 9.5, dilations. Hopefully you understand the dilation images of figures. This is our first transformation that is not in isometry. So remember, dilations create similar figures, not congruent figures. Thanks for your attention, and I will see you guys soon.